Hooking up the interpreter. The visit methods are sort of the guts of the interpreter class, where the real work happens. We need to wrap a skin around them to interface with the rest of the program. The interpreter's public API is simply one method. So here in class interpreter, in still interpreter.java, we will create this void space interpreter parameter xpr space expression with its statement, or with a body that has this statement. So try, inside this try or this body is first statement object space value equal evaluate parameter expression closing statement. Next statement system dot out dot print in parameter stringify parameter value closing statement closing body. Then next statement would be catch parameter runtime error space error, and then its body, it has one statement locks that runtime error parameter error, then closing. Now this takes in a syntax tree for an expression and evaluates it. So this void space interpret with the parameter xpr space expression takes in a syntax tree for an expression and evaluates it. If that succeeds, evaluate method returns an object for the result value. So if that succeeds, evaluate method will return an object for the result value. So it's actually returning an object for the result value, not just a value, which we may have thought of since the tree is being converted to a string, right? But here it is more nuanced. It's returning an object. So interpret method converts that to a string and shows it to the user. So to convert a lock's value to a string, we rely on this private method, which is private space stringify parameter object space object. And then its body, if parameter object equal null, return nil closing statement. So this is the first statement. It's still in interpreter.java, and then we would add this after is equal method. Okay, so next statement after the if parameter object equal null return nil is if parameter object space instance of space double its body string space text equal object that to string method closing statement. The next statement would be if parameter text that ends with parameter quote dot zero its body, there is a one statement in this body of if text equal text that substring parameter 0 comma text that length method minus 2 closing statement. And the next statement closing body of this if, the next statement returns space text closing statement, then closing semi-curly bracket. Then next line would be next statement would be return space object that to string method, and closing statement, then closing semi-curly bracket. So this is another of those pieces of code like isTruth method that crosses the membrane between the user's view of locks objects and their internal representation in Java. So this is another of those codes that blend or have to deal with the Java implementation, because we're creating language we're creating locks language. So their name kinda have to collide somehow. So it's pretty straightforward since locks was designed to be familiar to someone coming from Java. things like booleans look the same in both languages. The two edge cases are nil, which we represent using Java's null and numbers. LOX uses double precision numbers even for integer values. In that case, they should print without a decimal point. So LOX, since LOX use the double precision numbers even for integer values, they should print without a decimal or dot. Since Java has both floating point and integer types, it wants you to know which one you're using. It tells you by adding an explicit .0 to integer value doubles. We don't care about that, so we hack it off the end. Yet again, we take care of this edge case with numbers to ensure that glocks and clocks work the same. Handling weird corners of the language like this will drive you crazy, but is an important part of the job. Users rely on these details either deliberately or inadvertently. And if the implementations aren't consistent, their programs will break when they run it on different interpreters. Reporting runtime errors. If a runtime error is thrown while evaluating the expression, interpret method catches it. This lets us report the error to the user and then gracefully continue. So again, if a runtime error is thrown while evaluating the expression, interpret method catches it. So the interpret, this void space interpret. This lets us report the error to the user and then gracefully continue. All of our existing error reporting code lives in the logs class. So we put this method there too. So all of our existing error reporting lives in logs class. So we would put that in logs.java as well. So as you can see, these are just class. The .java, the logs.java, interpreter.java, parser.java. It is a class that is a deep module. So here, we would add after error method in the logs.java, static space void space runtime error, parameter runtime error space error. And its body would be system.err.printin parameter error.getMessage method plus code/n and then open square bracket line closing code plus error.token.line plus code closing square bracket then closing parenthesis semicolon. Then next statement, had runtime error equals to true closing statement, then closing. So we use the token associated with the runtime error to tell the user what line of code was executing when the error occurred. Even better would be to give the user an entire call stack to show they got to be executing that code. But we don't have function calls yet, so I guess we don't have to worry about it. After showing the error, runtime error sets this field. So here in logs.java in class logs. So inside the logs.java, inside the class logs, under static space boolean space had error equals false statement, we would add this static space boolean space had runtime error equal false closing statement. Now that field plays a small but important role. So here it still unlocks the Java in run file method under if parameter had error system.exit parameter 65 statement. Under it we would add this if parameter had runtime error system.exit parameter 70. So if the user is running a log script from a file and a runtime error occurs, we set an exit code when the process quits to let the calling process know. Not everyone cares about shell etiquette, but we do. Note, if the user is running the REPL, we don't care about tracking runtime errors. After they are reported, we simply loop around and let them input new code and keep going.